With the SHE, our standard hydrogen electrode, now we can put different electrodes with the SHE and get so-called equilibrium cell potential. So any other electrode or redox pair would be compared with the SHE. And in this case, we're comparing the zinc 2 plus redox pair or electrode reaction versus the SHE. How is it SHE? We are bubbling hydrogen into acidic weak acidic solution that contains proton, and we have platinum inserted into the acidic solution, and assuming the activity for proton in the solution is 1, while the pressure for the hydrogen gas is 1 atmosphere. And the platinum is activated, which means platinum foil covered by platinum black powder. Okay, under such condition, an equilibrium cell potential can be obtained through construction of such an electrochemical cell. 2 chambers, one for zinc ion, the other one for hydrogen, proton, but with inert platinum electrode. And the 2 electrodes are connected through an infinite resistance voltmeter, and in between the 2 containers we have a salt bridge that prevents a mixing between the zinc ion and the proton, but allows the anion or negatively charged ion to travel through. Okay, for such a electrochemical cell, an equilibrium cell potential can be obtained, which is essentially the electrode potential for that electrode. In this case, the zinc 2 plus zinc redox pair, or just the zinc 2 plus electrode versus the SHE or standard hydrogen electrode. If you also make sure that the concentration of redox species, for example, the zinc 2 plus ion, the concentration is standard, which means the activity is 1 molar 1, then the obtained equilibrium cell potential would be called standard electrode potential for that particular electrode or redox pair. So for our example here, zinc 2 plus zinc as 1 electrode and our SHE as the other electrode. Under standard condition, 25 degrees C, 1 atmosphere of hydrogen, and the measured equilibrium cell potential for zinc side versus platinum side is minus 0.763 volts, minus 0.736 volt. And this would be the standard electrode potential for zinc 2 plus zinc electrode reaction would be minus 0.736 volt. Or we can also say that the zinc 2 plus zinc electrode is 0.763 volt more negative than the SHE or proton hydrogen electrode reaction. This is the definition for standard electrode potential. You construct an electrode, put it against the SHE and measure the voltage versus SHE. And in this case, particular zinc 2 plus case, if the concentrations is standard 1 molar, then the measured equilibrium cell potential for zinc 2 plus versus hydrogen is minus 0.73 volt, meaning the zinc side is more negative by 0.763 volt versus the SHE, and this becomes the so-called standard electrode potential for this zinc 2 plus zinc electrode, or sometimes we say zinc 2 plus zinc pair. And in this case, if the electrochemical cell is connected through an external circuit with finite resistance, which means replace the voltmeter with a finite resistance. Then, as we said, zinc side is more negative. The zinc electron flow out from zinc, and the zinc side will go through anodic or oxidation half cell reaction. Zinc becomes zinc 2 plus, give out 2 electron, and the zinc 2 plus got dissolved into the solution. On the other side, the proton in the solution combine with the electrons released by zinc to go through cathodic or reduction half cell reaction to become hydrogen gas. Okay? Anodic half cell reaction, cathodic half cell reaction. Then the overall of full cell reaction would be just left plus left, right plus right, with the goal of eliminating the electrons from the overall reaction. And this is what we got. The overall reaction would be zinc plus 2 proton to become zinc 2 plus and a hydrogen molecule. Okay, so now we see the definition for standard electrode potential. It is obtained by putting a redox pair, in this case zinc 2 plus zinc versus SHE, and measure the potential difference with the assumption that it is under standard condition.